artificial intelligence. Some say it will save the world. Others say it will take all our jobs. There is a truth in between. Let's speak about it. AI without the PhD, because somebody has to translate this stuff.
AI without a PhD because somebody has to translate this stuff. And today I want to speak about the most unsung hero in AI industries. It's the data engineer and the data architect. Because nowadays, if you want to do something, whatever, people first cry for an AI engineer to hire, to staff, whatever. But I think this is not the right way of approaching an AI problem, because the biggest problems I see in the field, I see when I speak with people and I read in literature, is not the model. The model is perfect fine, but the data that's going in is what kills the model. And this is pretty simple to frame: shit in, shit out. So if you don't get your database sorted, organized, classified, and just give a bunch of bytes to a model, you get horrible results. And at the end, people will blame the model, the initiative, or the approach, but they will never blame the data underneath. And I think this is wrong, because first you need to sort your foundation. So let's drill a bit in there. So when I see people speaking about AI, I tend to ask the first question. Interesting, but what data are you planning to give your model? And this is where the answers become usually pretty short, and pretty short, because this is something people never think about before they start an AI initiative. They discuss a lot about the right model. They discuss about the vendor. They discuss if it's on-prem, if it runs on a MacBook Mini under their desk, if it's run with PI data, whatever. But they don't discuss about the underlying data, how they format it, how they collect it, and how they feed it to the model, and especially not how fast they feed it to the model. So let's speak a bit about the translation, what the data engineer actually do. And I don't want to start with technology. So no matter if it's Kafka, Flink, Snowflake, Databricks, MongoDB, whatever. So completely independent from the technology. An AI, the data engineer is starting with a problem. And this is where they start their work. So they speak with the business and ask if they produce information constantly. They think about how customer order stuff. They think about how and when a payment happens. They think when a package is shipped and moved and how do they get the data. They know when they know how to get the data if a flight is delayed. They know how to get information about a product specification. And this is where the data engineer's job is becoming very essential. So that means such answers like where does the information comes from is usually answered by a data engineer. What does this piece of information means is answered by a data engineer. And it can be really messy if you have companies with a long and rich history. So sometimes you see data that's still shipped around in XML and you see the order status is 5. This is absolutely not helpful for a model, because 5 can mean everything between order placed, order shipped, or payment failed. So those answers are given by data engineers, and they know it, or they investigate into that. They can make or they can make statements if data is completed, if data is valid and correct, or if data may be missing parts or have inconsistency in that. So if we want to take a bit of an analogy, and it's evening in Melbourne, so I'm getting a bit hungry, and let's think about a restaurant kitchen. So the AI model is the celebrity chef. Great. They make amazing food, they make amazing dishes, they dress the dishes super nice and ship them out. But somebody still has to buy the ingredients to check that they are not rotten when they go into the kitchen. Someone needs to store them correctly regarding their temperature needs and whatever. Someone needs to label everything. Someone needs to make sure that the items arrive before dinner time, and someone needs to prevent the dishwasher to put dishwasher soap into the soup. So you see there are lots of moving parts, and the dishwasher puts liquid in the soup. You have those guys in your company. You don't have them in restaurants, but you have them in the company. So a project that starts on the scratch, on the green field, and they just want to rapidly go into production, and then they do shortcuts in the data format, or they don't align the data format at all with anyone else. And so you have inconsistency in there. And this is where you have data engineers making sure that this is not happening. And if it's happened, to investigate who did it, who broke the contract, and who need to fix that. So coming from an AI demo to an AI system, and there again, a lot of misunderstanding. So AI demos are great. They are remarkable. You throw in a model PDF, you get asked some questions regarding the PDF, and you get the answers. Amazing, and management is cheering, C-level is buying, everything is good. And now we come to the point that this demo becomes a system. And when this demo becomes a system, it starts to get more ugly. And then it's maybe not a model PDF. So it's a PDF that was created by a free available open source PDF converter that uses a slightly different format, which is still PDF format, but maybe not the format the model expects. Or let's speak about, the AI demo is wonderful looking. You ask about your flight. It says the flight is delayed by 2 hours. It offers you rebooking, and you rebook, and everyone is happy, and the demo is done. But now you want to get this into production. So you need to connect to APIs. You need to know if a flight is delayed, how much it is delayed, why it is delayed, because if the delay is caused by weather at the destination or the departure airport, then most likely the next flight is not helping at all. So you may need a different routing, or you can send the customer straight to the hotel for the night because next day the weather is better. So, but you have to interact now with those APIs, and this is where the demo hit the reality. And the reality is maybe messy, because maybe you don't get the updates in time. Maybe you get the updates in 3 different formats because you have to query 3 different systems. And this is everything an AI engineers not taking care about. The AI engineer makes sure that the model is working fine. The AI engineer makes sure they choose the right model for the right purpose. They configure the reasoning, they configure the properties, the configuration. They may configure a prompting if you work with an LLM, but they are not fixing the data issues underneath. This is the job of a data engineer. And that is why I truly believe you need a data engineer first, because you should consider any AI initiative. Because there's nothing worse than having horrible data and you put that on scale. So AI is just not needing data, it needs a context to work in most of the cases. And this distinction is very important. People often say we have loads of data. That's wonderful, but so does the internet. So that doesn't mean that the model is able to answer your question because you threw tons of data in there. Even the opposite, if you have a true broad training base for your model, or a true broad context for your model, it's more likely that it starts to hallucinate. So the idea is not to throw as much as data as possible in there. The idea is, with a context and with a training base, to throw accurate data that's needed for the purpose into that. So what does that mean? Imagine you have a record customer 42, status gold. That looks wonderful, but what does gold technically mean for you? Is it a gold loyalty member? Is it a gold credit risk? Is it a global gold support tier? Is it maybe a gold subscription? Or is it maybe just a thing how you classify your customers? So the context is very important to know what this gold in that case means. And perhaps the customer became platinum yesterday, but your data warehouse is not providing those data. And I had the discussion with my colleague who is with me on the business trip. She became gold member at a hotel loyalty program. But we switched hotels. So we flew down from Sydney to Melbourne, and she got the gold tier awarded with her stay in Sydney. And when she checked in Melbourne, she wasn't able to get the gold benefits because they still had the silver. And that was because the loyalty program does the upgrade overnight. So the hotel in Sydney credited the points to her account. So they are technically in the account, but the batch shop is processing this, and the batch shop will figure out by night that she is now a gold member. Unfortunately, not helpful for the check-in here because there she's still considered a silver member, getting lesser perks. And this is also something data engineers are helpful to discuss with, how to keep the data updated and most accurate for the time being. When we speak about AI, another important thing is with the EU AI Act, for example, and there are more and more governance topics coming in by legislation to make AI predictable. And therefore we speak about data lineage, data quality, metadata, semantics, freshness, and ownership of data. And all of that is not done by an AI engineer. They don't care because they don't have to care. They get the data, they take it, they run the model, done. It's an important job, and it's way more than I just described now. But this is what they do. They take care about everything around the model. They are not fixing the underlying data issues. And this is, I know that I repeat myself, but it's that important. I can't say it enough. There is a differentiation in the job title, in the job role between AI and a data engineer. And you can't fix it by just burden this to the AI engineer to have a fancy title and attract talents. There are a lot of talented data engineers around there as well. And it's a different kind of work specialization. So I don't think it makes sense to combine this into roles. You would never put the sous chef and the dessert chef, and if the one is doing the dessert, it will maybe not that tasty if you have a specialist doing that. So please keep in mind that you staff for the purpose of the role, and you staff for the purpose of the function. So the data engineer, they will take care about the lineage. They will explain, they will explain where data comes from. They are able to identify it. It's their job to know. They also able to discuss freshness. When is the data produced, how it is aggregated, how it's consolidated, and how it hit the model. They will explain semantics, which is important, as I mentioned before. So what does gold mean in that certain context? And this is what you have there. Let's speak a bit about garbage in, garbage out, because this problem is more dangerous if you work with AI. Garbage in, garbage out is a thing that is out there for decades. And we speak about that when we deal with data. We usually come to the point where we speak about that. And AI is not fixing that. AI is exposing this. Because if you have garbage in your data and you threw it on an AI model, that means the model will just put this on speed. So depending how you build your AI products, your AI initiatives, even AI is feeding into AI. So you build a multiplier in there. And that's dangerous. The second thing is, if you have garbage, a model is not failing. And that's an important thing. A model is not failing. If you have garbage and you do a REST call, you call a website, and there is something wrong, it says error 503, error 500, 404, not found, whatever. So the traditional software is designed to fail. Unfortunately, AI models are not failing. They just give you false information. And the false information is, without guardrailing, not flagged. So you won't see any error message in your logs. You just get continuously false information. And this is something you really have to keep in mind. And this is where guardrailing comes in place. This is where lineage again comes in place. And this is where you need, again, the data engineer. So it's complicating. So let's go down. So let's imagine of an AI assistant answering, according to corporate policy, employees are entitled to. which is a beautiful grammar, which is a confident tone, but maybe it pulls the policy from 2019 and not the actual one, because the actual one is not discovered, the actual one is not sent to the model, it's not loaded in the context, whatever. So did the model work well? Yes. Did it pass the test? Yes. Does it throw an error? No, was able to answer. Is the information correct? It isn't. And this brings you into problems because there are more and more court rulings answering the question, who is responsible for those errors? The entity who provides the AI assistant. So if this goes down, there was an Air Canada case in February 2024 where the chatbot of Air Canada invented its own refund policy. And there was a case and someone went to court and the judge filed Air Canada guilty and orders Air Canada to pay compensation. And imagine this happens to your bot. You don't have guardrailing, you have all the information, and the bot is just trying to answer with whatever they have in context, whatever they have accessible, whatever they can read, and they give false information, you may be responsible. So that's why data engineering, guardrailing is an important thing. So let's cover quickly the real-time problem. And this is something where change is happening. So historically, enterprises moves in batch. They take the data, they load it, they train, and then they spit out a model and they keep the model running. So this was fine. But nowadays, the world is moving way faster. And here again, we speak about data freshness. So this is something a data engineer would take care about. So imagine we have fraud detection and the fraudsters are learning themselves. They move their pattern, they change their behavior. And if you have a model you trained a year ago, well, it won't get the transaction fraud you will see today because the fraudsters moved on and your model didn't move on. We call this in industry data drift. This is where the reality drifts away from the model. And again, the problem is you won't see it in the logs. You will see it when you have a lower detection rate on fraud. You will see it when you have a lower conversion rate because your recommendation engine degraded. And you will see it in the results. You're not seeing it in the logs. So there are two important real-time use cases. The one real-time use case is the use case where you control your model and see if it's still accurate and if it's still on top and if it still does recommendations that convert into other sales, other clicks, and whatever you want to achieve. You see it in the metrics if you check on how much fraud is prevented and how much false positives you have. So there you have the loop where you can control the model. You can't control it in the logs because it will never say, oh, error, this is a transaction I wasn't able to flag. A model will always make a confident answer and it will always come to a confident solution, but it may not fit the real life. So with that, let me come to the end. So AI agents, and this is the last part I want to cover, are making engineering even more important because now we push it ahead one more step. So a chatbot gives answers and the agent actually execute them. So if we see agents, and I think I should do a full episode about this agent thing. Well, we did already, but I just went into what's possible, what's not possible. I didn't went into how it's working. But on a very high level, an agent is steered by an LLM. So you give an LLM a task and the LLM is accessing agents to execute things. It's like a manager who sent employees to do things. So agent go to the file system, agent find the Word document, agent open the document and fix something and store it back. This is where LLMs are working with the agent. But it's not only that. They can book flights, they can refund payments and stuff like that. As mentioned in the episode, I remember was about how to book accommodation on the island of Madeira at that time. So with those agents, you give the LLM a powerful execution layer. And this needs to be controlled and this needs to be the decisions need to be made on top of accurate, fresh, and correct data. And this is again only the point where the data engineer can help you with that. So let me close this and want to return to the opening. So you see the famous chef, which is the LLM, but you don't see the lines behind, the people who stock the goods. You don't see the people who wash the dishes and all of that. And this preparation work to let the chef shine in front of the customers and let the chef achieve a Michelin star, whatever. This is done by a bigger workforce behind the scene. And these are your data engineers, the data architects. That are the guys who do the pipe work, who make the plumbing for the data to get filtered, to get aggregated, to get context, to get value, and to get this to the LLM for things. So the smartest AI in the world is still only useful if the information are reliable. And this is the job of the data engineer, and that's why I think data engineers and data architects are the most underrated job titles in nowadays AI, because everyone wants to become an AI engineer, but those guys need the plumbing behind, and this is done by those job groups. And I think we can't mention this enough and make this clear and sure for the decision makers that they need to hire both and they have to fill both functions to make sure to get the best out of their AI initiatives. And with that, I'm done with this episode. Thanks for listening in and all the best. See you next time.